This is the video for lesson 1.3, adding and subtracting square roots. We will be looking at learning target 1.2, that you can simplify radicals and perform operations with square roots. This is the second lesson that we have addressing this learning target. In the last lesson, you learned how to simplify radicals, and this one we're going to extend it just a little bit more and not just simplify, but look at adding and subtracting the square roots. This is actually getting into the part that's performing the operations. So following along in your guided notes, I do have a section of review for simplifying square roots, mainly to address the square roots that have a number out in front of the square root. So if we go back and refresh ourselves on how to simplify, we're going to break this down into prime factors, and I know that 27 will divide into 9 times 3, and I know that 3 is a prime factor, and 9 will factor into 3 times 3, and each one of those are prime factors. So just as a refresher, I have a pair of 3's. I know that's what's going to come to the outside of my square root. And I remember that we just bring one of those out. So we have 4 times 3 on the outside. On the inside, we still have this 1 3 that does not have a pair. So 4 times 3 to square roots of 3. And go ahead and simplify that. 4 times 3 is 12. Square roots of 3. Okay, quickly go through the other two for review. Remember that 75 could be factored into 25 times 3. 3 is a prime factor. 5 is 5 times 5. Again, I have a pair of 5's there, so I know that's coming to the outside of the square root to join with the 6. And the big thing to remember is that we are multiplying that number times whatever's already out there, multiplying it by that 6. So 6 times 5, square root of the number that is left over, 3. 6 times 5 is 30, so this is 30 square roots of 3. Lastly, we have the square root of negative 3 square roots of 45. 45 will factor into 9 times 5. 5 is a perfect square. 5 is a prime number. 9 will factor into 3 times 3. So we have a pair of 3's that will come to the outside of our square root to be multiplied times the number that's already out there. So negative 3 times 3, square root of 5, because the 5 is the lone number by itself. Negative 3 times 3 is negative 9, and we don't do anything with the inside, times the square root of 5. Okay, so that was just a quick review of how to simplify square roots. If you need help with that, refer back to the last video in lesson 1.2. So when we start talking about adding and subtracting square roots, I want you to think back to adding and subtracting fractions, because we've talked about before that adding and subtracting, that with anything that we do, especially in algebra, adding and subtracting has certain rules to it. It will be much more difficult to add and subtract than it will be to multiply, which you will see in the next video. But thinking back to adding and subtracting fractions, I want you to pause the video for just a moment and tell me, what do we have to do in order to add and subtract fractions? Hopefully you said something about finding a common denominator. Remember that we have to have the same number on the bottom of the fraction before we can ever add or subtract fractions. And this is going to be similar in square roots. We don't have denominators in square roots, but we cannot add or subtract square roots unless we have the same number under the square root. Okay, so whatever number is inside that square root has to be the same, or else we cannot add or subtract them. It's kind of like having like terms. So let's take a look at some examples. The square root of 16 plus the square root of 16. We're going to do this two different ways so you can kind of see why we have to have the same number. But we know that the square root of 16 is 4. So essentially this is just 4 plus 4. Well, 4 plus 4 is 8. Well, we could also say that the square root of 16 plus the square root of 16 is 2 square roots of 16. We could add those together. I can imagine there's a 1 square root of 16 here, and there's 1 square root of 16 here, and I can add them together to get 2 square roots of 16. Again, we know that the square root of 16 is 4, so this is simply 2 times 4, and we still get the same answer. 2 times 4 is 8. So either way that we do it, we still get the same final answer. But I just wanted you to recognize that as long as we're adding the outsides of the square root, whatever number is outside the square root, we can write it in this form of 2 square roots of whatever. And that's really what we're going to be looking for, or how we're going to add our fractions. The key being that we have to have the same number underneath the square root. So you may ask, well, Mr. Colworth, what happens on the next one? We don't have the same numbers under the square root. In this case, we have to go to simplifying the 2 square roots. Well, the square root of 6 just breaks down into 2 times 3. There's no pairs there. Those are both prime numbers. So I can't simplify it any further. So we're just going to be left with the square root of 6. The square root of 24 breaks down into 6 times 4. And 4 breaks into 2 times 2. And 6 breaks into 3 times 2. 3 times 2. Well, notice we have a pair of 2's here, and the 3 and 2 will still be left by itself, so we can rewrite that as just 6. So this will be plus the 2 coming to the outside from our pair, square roots of 6. Notice now, after we have simplified, we do have the same numbers under the square root. We have 1 square root of 6 plus 2 square roots of 6. And we will only add the outside numbers. Outside and outside. So 1 plus 2 is 3. The inside stays the same. Think back to fractions, and we did not add the denominators. We only added the numerators. Similar here. We're only adding the outside numbers. So this would be 3 square roots of 6. And you can see why it's very important to know how to simplify square roots at this point, because we would not have been able to do this problem until after we were able to simplify the square root of 24. Let's do a few more examples. Again, we do not have the same number under the square root, so we have to try to simplify each one. The square root of 32 can be factored into 8 times 4. And 4 can break down into 2 times 2. 8 can break down into 4 times 2. And 2 times 2. In this case, we have a pair of 2's here, and a pair of 2's here, and one prime factor of 2. So with 2 pairs of 2, I would have to do 2 times 2, which is 4, and the lone 2 stays on the inside of the square root. Again, if that gives you trouble, make sure you refer back to lesson 1.2 on simplifying square roots. 8 I can factor into 4 times 2, and 2 times 2. I have a pair of 2's and one lone 2 here. So this would give me 2 square roots of 2. So now we do have the same number under the square root of each one, and we have 4 square roots of 2 minus 2 square roots of 2. 4 minus 2 is 2, and we don't touch the inside of the square root. 2 square roots of 2. Okay, so let's check these next couple of practice problems. The square root of 27, we can break that down into 9 times 3, and 9 can break down into 3 times 3. I have a pair of 3's here and a lone 3 there. So this is 3 square roots of 3 minus the square root of. Breaking down the square root of 20, we can factor that into 5 times 4. 5 is a prime number, 4 is 2 times 2, so we have a pair of 2's. And here we end up with 2 square roots of 5. So even after simplifying this one, we do not have the same number underneath the square root. So we cannot add, or in this case subtract, these 2 square roots. All we can do is just leave it in simplest form. So 3 square roots of 3 minus 2 square roots of 5. Don't get freaked out and don't get anxious about trying to do something more than you can actually do. We have to just leave it in this form that it's 3 square roots of 3 minus 2 square roots of 5. There's no more simplifying that we can do. The last one is the most complicated that you will see, and this is just one that already has the number in front of the square root. We're still going to simplify like normal because we don't have the same numbers under the square roots. This would be 25 times 3 and 5 times 5. We have a pair of 5's that's going to come out and multiply with the 3. So that will be 15. And the lone prime factor of 3 stays on the inside. The square root of 50, same deal, 25 times 2 this time, 5 and 5. The pair of 5's is going to come out and multiply with the 2, and I have a lone factor of 2 on the inside. So this will be minus the 10 square roots of 2. Again, I do not have the same number under the square root, so I can't simplify it any further. So this would be 15 square roots of 3 minus 10 square roots of 2. And that's as simple as we can make this expression. Okay, so big things to remember is that the inside must be the same. The inside must be the same in order to add or subtract. And we're going to add and subtract the outside to outside. And you can disregard this second part. That will be coming up in the multiplication section, but we only add or subtract the outside to outside. There's nothing else that we add or subtract together. We leave the inside alone. Leave the inside alone. Okay. So make sure you bring any questions that you may have to class, and we will do some more practice with these and have you prepared for the unit test.